Hey everybody, so in this video I want to show you how to wire up a battery management system on this lithium iron phosphate battery pack here, where I'm upgrading this off-grid solar setup from these lead acid batteries set up here to the much higher capacity lithium iron phosphate batteries from CATL. They're 280 amp hour cells, and I'm gonna show you how I wire up the battery management system here from Over Kill Solar. I saw a video a while back. Will Prowl shows on his channel how he really liked these, and they really worked and are a reliable battery management system. And you can see here that it's a 100 amp 8S or 8 cell 24 volt battery management system, and in each one of these banks there's 20 cells. So this row of 10, so we have 8 cells and then 8 cells, which leaves 4 remaining cells, and then the exact same with that one. So we'll have 5 sets of 24 volt batteries in this whole bank. So I'll wire these 4 up with those 4 and make those a set of 8. And so we'll have one of these on each set of 8 cells, giving us 5 cells, or five sets of 8 cells. So that'll give us a 500 amp output capacity on this whole bank. And so I wanted to show you all the tools involved with this whole operation here. Got the angle grinder with the cutoff wheel, so you could see here how all the tabs are set up. So this is our 8th cell, so I'll have to cut that, and you could see I've already done that here. And then this must be pure aluminum. It's really soft, so easily bent. Made the cut, bent it up, and then drilled a hole where I could mount a lug on that. And you could see here, because this wire connection, you could see how each one has a battery these are the temperature sensor, but has the battery voltage sensing wire. So when I cut this one, that wire was on here, so I had to add my battery sensing wire for this cell like that. Pretty simple. Drill a smaller hole, stainless bolt with the crimp connector. And yeah, so back to the tools involved in this setup. We got the angle grinder with the cutoff wheel to cut those tabs, the drill to drill the holes, soldering gun, and some Radio Shack resin core solder. Radio Shack, remember them? Some heat shrink, some basic hand tools here, crimper to crimp that lug, a wire, or a voltmeter to verify that I'm doing everything right, and our battery management system from Over Kill Solar. Really good company, I like them. And with each unit they send you a report of the quality control and show that it passed all the tests they do, and give you a cool little free packet of high quality zip ties, help you manage all the wires, and comes with the Bluetooth module, so you could see all the data about the battery on the app that interfaces with that, and also send you a easy diagram that couldn't make it simpler on how it's exactly set up. Yeah, I've been using Over Kill Solar's BMS system in my off-grid setup for years now with really good reliability, and they've just been working and working without any issues. So yeah, highly recommend them. So we're gonna go ahead and do it on this pack. I just wanted to show you really high quality battery. You could see it's got a fan right there and a channel in here, and between each cell has like a heat sink with some thermal compound between. So if you needed to cool them off, the fan will blow air in there and be blowing out all these vents on the battery. So I'll set up a temperature control that controls that fan if they get up to a certain temp, and then shut back off once they get cooled off to a certain temperature. So all right, let's get into some electrical engineering here and get a battery management system wired up on 8 cells on this pack. So you could see I wrote with a marker just to keep track. Okay, there's my 8 cells. So I'm going to cut this here. And then same thing on the other side. There's my 8 cell. So I'm going to cut that there. Yeah, and we got these batteries from batteryhookup.com. Another great company I really like. Good people, sell good products, and test them, and you know what you're getting versus just buying anything off of eBay or wherever. So yeah, batteryhookup.com. Yeah, and another thing that I'd like to mention about David Poz's video, David P-O-Z, and thanks David for putting that video out on when you converted one of these batteries to an off-grid setup. He actually cut some of these cells out, and at the end of the video he said he probably would have actually left them intact and just wired them up as they are, because they got these compression bands, and I guess these kind of cells are better off to be compressed properly. So yeah, I'll be leaving them intact as they are, and wiring them up like that. And yeah, and a shout out to Will Prowl for doing a cool video on these Over Kill Solar BMS units. Thanks for that. And so I think it couldn't be easier to make this type of battery pack into into a off-grid setup, especially being that the all these wires are kind of already all wired in. You just got to find which wire from each cell. So I'll show you how I'm going to do that. Which wire from each cell is which wire here, and then we'll connect these up to the wires that plug into our BMS. And then another thing I'd like to mention when working on stuff like this is you gotta work with a heightened sense of awareness, being that there's an incredible amount of energy sitting here, and you don't want to have a metal tool touch and short those out, or you'll instantly turn that wrench red hot, maybe melt it right in half and send sparks and molten metal around. So you gotta always keep that in mind when working on battery banks. It's like a sleeping giant inside each cell that could be released in an instant of a second. So yeah, just one thing I want you to keep in mind when working on any battery packs. We don't want anybody getting hurt. Okay, so we got our voltmeter set to DC volts, and we're going to measure the voltage on this cell. So we could see we got 3.3 volts. So I'll leave this probe on this terminal of the cell and then test this wire and see we're getting the same voltage. So that tells me that this wire is connected to this tab here. So now we're gonna solder this wire to the proper wire on the that goes to the BMS setup. And so I don't have any diagram of which wire is which on here, so we're just gonna have to pick our way through it with the meter and test each one and verify which cell it's going to. And that's pretty easy and straightforward. With the meter, we'll do a couple of them and you'll see how the workflow goes. Yeah, so this is the first wire we're hooking up, and you can see right there, that's the positive terminal on that cell, so that means this one's a negative. So if we look at the diagram here, we could see that this is the negative cell, gets hooked to the black wire. This is the wire that plugs into here. You can see there's one black wire on one side and one red wire on the other, just like in the diagram there. So pretty straightforward. So we know we're going to hook our black wire to that wire we just found that hooks to this negative terminal, the first one, first negative terminal on this side of the battery cells, which is, we just verified, is this wire. So we'll solder those wires together and show you my technique how I solder those. Alright, so our soldering gun is up to temp, and what we'll do is we'll slide on, take our piece of heat shrink wrap, slide it on first. You don't want to forget that. Like that, much better than just wrapping it in electric tape. And then we'll saturate the wire like that. And then we'll take our black wire. I really like these kind of strippers. Strip them about the same length. And then I'll use these little things to hold it for me. And same thing. Saturate that piece of wire. Like that. And then that wire is kind of holding itself, and I'll use my other hand to hold this wire, and I'll lay them side by side, and I could see the solder just melt them both together. And sometimes it leaves this little sharp thing, and after it sets up and solidifies, I'll just quickly drag that over like that, and I can turn it and see that we got a good solid bond. And then slide the heat shrink over there with the lighter, and boom, you got a nice solid protected connection. So now we'll find the next connection. So I could see here, this wire is green. So we'll put our wire cutters, cut them, do one wire at a time, and that way things don't get confusing, or less chance of one wire touching another wire and shorting something. All right, there's our green wire. Take our strippers, Strip that. Get our voltmeter, set it to DC volts. And then we'll test from this cell, that cell, you can see it's 3.3 volts. 3.3 volts. Okay, so we know that's that wire. And it's still the same 3.3 volts because we're still only measuring the one cell. Once we get to the next one, now the voltage will start adding up from cell to so like from this one to that one. I don't know if you could see the meter, but now we're 6.6 volts. So 3.3 and 3.3, and it'll start adding up. And so also keeping that in mind to keep track of what the voltages should be reading. So now, going back to our diagram, we're on the next one right next to the black. So they're not numbered. You just basically go from the next, just like in the diagram, the next wire next to the, and we just work our way this way from the black wire, since that's the direction we're starting from on the cells, basically. Doesn't matter which way. You could start from the other side and work your way over from the red wire, whichever way you're working, or whichever way you start. So we'll get the next wire and single it out, the next one over from the black wire, and strip that. And same procedure. Saturate each one with solder and then fuse them together, and don't forget to put the piece of shrink wrap on first. I like to twist them too, just to keep them nice and tight together. So here, let's do it again so you can see. Put this over here so you can see a little more clear. We'll put our little helping hand thing there to hold this wire, so I could hold the soldering gun in one hand and the solder in the other hand. Fumes off the soldering gun are super toxic. Hold my breath basically in this particular situation. Just some smoke comes off for a second, and I'm holding my breath then. Okay, got my shrink wrap on, both ends saturated with solder. Set this out of the way, don't want that to touch anything. And then bam, fused together nicely. No little sharp things of solder poking out. Let's see if I can get a close-up of that. See, real nice bond. And slide our shrink wrap over. And that's how we start doing our connections. Reliable connections. Other ways to do it, but that's the way I'd like to do this sort of thing. All right, yeah, so we'll keep working our way all the way to cell number 8 that same way. So next, so we could see now the next one is this wire here. So we went from this one to this one to that one, and we'll work our way. So this next one's yellow. I could see there's only one yellow in this whole bundle, so test it the same way though to make sure, instead of just assuming that's right. Test the whole way, make sure, use the same procedure. And then that way we know things are going right. Yeah, and because of how toxic the fumes are off that soldering, I got this door open here and this door open here. I'd never be soldering in an enclosed room because of that, unless I had some filtration or fume extraction, and even then, still wouldn't want to be soldering in an enclosed room. Just a thing to keep in mind to protect yourself from something that's super toxic. Okay, so important thing I want to point out to you to keep from being confused about where you're testing from and whatever. So we got our negative. That's a negative of all the cells together, and so we got our probe on there, and so you could see from just that cell 3.3 volts. Now when we jump over to the other cell here, it's still this same tab, and the voltage doesn't add the other cell until you get to the other terminal. That's why these tabs alternate, and that's how you start stacking the voltage. So we're always got this one measuring from here, and so you could see here 3.3, and then 6.7, 10, 13.3, 16.6, 19.9, 23.2, and then the final one is 20, and so we could see 26.6, and then jumping right over to here, 26.6, and that's the wire connected to here. So we'll hook our final red wire that plugs into the BMS solder to here, and then we'll be ready to move on and plug that into the unit and connect these two blue wires onto the negative. So I'll show you that. Okay, one little detail I want to point out here to avoid any confusion to anybody that's new at this sort of thing is, it's one thing if you're starting with a battery pack that doesn't already have these voltage sensing wires connected to these points on the cells here. And if that's the case, you just, you're wiring up to, as the diagram shows, right to, from each connecting tab on the diagram from each cell in the bank. But if you got a situation like this where a pack's already made and it's got the voltage sensing wires and you're trying to find those, on this first one, in this case, we could see like this is our negative on the end of the voltage, or the end of the pack, the string of volts or battery cells here. So normally we want to be measuring, everything from this one. We'd be measuring from this one to that one to that one and so on. But because this wire is here, just in this case, we're going to be measuring from this side of the cell to find this wire in the pack of wires in the connector here. So just a little detail I wanted to point out, you know. And then once you found that and know that, you know, this black wire is that black wire over here, then, you know, from then on, everything's being measured from there to verify, you know, this yellow wire is that yellow wire over here. So we're verifying that, you know, like the voltage on this measurement, leaving this probe on this connection, and then we're finding the wire that matches the same voltage as when we're reading that, which is 6.7 volts. Sun's kind of putting a shadow on it, but yeah, so you get the idea. So just wanted to point that little detail out to avoid any confusion that anybody's new to doing this sort of thing. And yeah, there we go. Okay, so we're going to go ahead and cut this and separate these 8 cells from the other pack very carefully with the angle grinder. Now we'll get those pliers and bend that up. Okay, so we got this cut here to isolate this from these cells, and of course I wore one of these and some safety glasses while cutting that with the cutoff wheel. Highly toxic dust, don't want to breathe that. So now we're gonna bend that tab up real carefully with this tool here. Pretty soft aluminum. These duckbill shaped channel locks work nicely for that. So there, just bend that straight back up like that. And then now we'll drill our hole in here to be able to mount the terminal like that on there. And then doing that in such a way to not put so much stress on this too. Just about how you're applying the forces. Yeah, so pretty much like that, pretty straightforward. Nothing complicated about that. Okay, I got a red dot right there where I'm gonna drill my hole. And then being careful not to let this touch and short out any of these. Just basically keep my hand there like that. All right, there we go. But now, because of the aluminum so soft, we got a pretty good sized burr. So I'll use this deburring tool to get the burr off. That gets most of it off on this side, but because this is here and I can't use that tool there, and the aluminum's soft enough, I can pretty much cut that burr off, which is bigger on this side because that was the exit of the hole. Just real carefully, I can shave off that burr. And this is another little detail I wanted to point out to you, is because of the way these are, these are bent. So when you cut that and bend them open, it's hard to have it perfectly flat. So that means when you bolt your lug on, you don't have as good of contact as bolting onto a flat surface. So what I do here is I take a grade 5 bolt with 2 grade 8 washers and 2 box end wrenches, and tighten that really tight. And because it's fairly soft aluminum, basically that reforms that flat tighter than I could ever squeeze it with any pliers or channel locks by cranking these tight. So yeah, so now that reformed that area where we're going to be tightening that lug onto, and yeah, I could see how it took that area under the washers, that took the buckle and the metal out. So now when we bolt that lug on, we'll be getting better contact. It's all about the details, doing quality work. All right, so we're about to wrap up this part of it. So we could see here that this is all wired up nicely to all the cells as the diagram shows. And then you could see here there's blue wires and black wires. So you could see there's the BMS unit there, and the blue wires hooked to the negative terminal, which is this here. So and then now we'll go ahead and plug this in. So you could see that the black wire is on the right side and the red wire is on the left side. So just like that, we'll go ahead and plug it in. You can feel it click in. And now I could go ahead on the app now. So the two that I already have hooked up to the other one, I already renamed them 1 and 2, so you could see I wrote number 3 on there, and that's how I'll keep track in the app of which one is which. So this is, and you can see when I click on that and it's trying to communicate, that little blue light on the Bluetooth module will come on. And there we are, we're connected. We could see the voltage. So, and I can go ahead and shut off or disconnect so no power could come through. So right now this is live. So if I put a voltmeter from there to the positive terminal, we'll read that voltage, 26.3 volts. So we could see all the voltages. You could see that we're 0.02 of a volt difference on all the cells. So they're really nicely balanced. and we could see the temperature of the temperature sensors. So I'll go ahead and shut off the discharge port, just so that terminal is not live right now, just while I'm setting this up. Yeah, so yeah, that's the app right there. And let's see, Overkill, on Overkill Solar's website, they have the app you can get, and it's really cool. I gotta say, you could see everything. It's like a window into the battery. You could see everything you want to see when it's charging. You could see in volts and amps right there what's coming in. When it's discharging or drawing power out of the battery, you could see volts and amps there. And I got to reset up, like it says 100 amp hour. These are 280 amp hour cells. So I'll go in the config and set up a couple things. And that's another cool thing, is you can reconfigure it to your values. And you could see everything you would want to see: over voltage, under voltage, over temperature, under temperature, over current, how many overcurrent times it happened, the short circuits, single voltage, over voltage, or under voltage. Yeah, everything you could possibly want to know. How many cycles. So yeah, I gotta say, that's really cool, and I really dig this setup. So there you go. There's how we set up the battery management system from Overkill Solar. And another thing I'd like to say is, we all need some decentralized power. Last thing we need is somebody else controlling things that we need. So here's some tools to do that. And you hear that saying, don't try this at home. Well, I'm going to tell you, try this at home, because we need everybody to have decentralized power. I'm all about off-grid system, really not interested in any grid tie setup. And yeah, so we'll keep the videos coming, and I'll show you once I get this all set up. And I'm gonna make a rack that fits on nicely, and mount those BMS on a board on the side of each pack, and get all the wires tidy up. And also, I'm gonna put a fuse right there, so the fuse will come right off the battery, and provide another layer of safety. And then all those 5 24-volt batteries in this bank will all go into bus bars. So all the positives will go into a bus bar, and all the negatives go into a bus bar, and each group of cells will have their own fuse right off the pack. So, all right, let's keep the juice flowing. All right, so you could see that the output is on. So I could go ahead, and I got the other terminal on the, you could see there, I got that lead on the final terminal, the positive one. And then we could see here, when I touch this on here, oh, that fell off. 26.6. So everything's working right now. I could go ahead and shut that. Go ahead and shut that off. Confirm, yes. So now the unit is basically like a big switch, and there's a little leakage voltage, but won't let any current flow through until that gets turned back on. So just wanted to show you that. And another thing I wanted to point out about this setup with the BMS on your bank of cells is that our positive and negative of the end of the string of cells is positives here and the negatives there. But now to have the BMX or the BMS in the loop, so now the negative is connected to that, and then that's going through the BMS, and now our positive and negative are here, and that's where our where we'll hook our loads to is here. And so we could see here the blue wire, this is coming from the negative, and if you hook it up wrong on that, you're gonna fry that. So you definitely want to get that right. Got the blue hook to here, and then the black wire coming from the BMS is now this negative terminal, and then the positive terminal on the string of cells is there, and this is now the negative, the black wire coming off of the battery management system. So I just wanted to make sure to point that out, and then that's how in the app on there you would see the load in volts and amps coming across there, and the charge in volts and amps coming into that, or going in through the BMS. So yeah, just wanted to show that and point that detail out too. And on this particular project here, these high quality battery packs that I got from Battery Hookup made by CATL came in a nice metal tray, really heavy duty strong tray. So I just took some angle iron like this, welded some wheels on there, and then bolted it. Put a bolt through here and a bolt through here, and then this side had a metal sticking out here with slots for bolts. So I ended up putting that like that. You could see bolted on real securely, and we're 800 pounds here. Can easily roll that and move that around. And there we got a little rack system going. So I'm pretty proud of how that turned out. And then as I was explaining how, we have our 8 cells here, and then our 8 here, and then we have our 4 remaining. So with this wire here, we jump down to these 4 cells to connect this string of cells up, and we have our 5 battery management systems. I'm gonna make a board and mount those a little better and tidy up the wires a little more and stuff, and then have a plastic cover that goes on top of there so nobody accidentally touches any metal things together. And yeah, we're ready to get the fuse links on the terminal coming off the battery, and get this plugged into the solar setup here. And then here you could see, here's all the battery management systems, each one talking to the app here. And so as I did one, I wrote with the marker BMS1, and then I went in the software and named that one BMS1, and then on to the next one. And we have our 5 separate 24-volt battery modules with their own 100-amp battery management system installed and set up and talking to the app nicely. So I'm liking how this is looking and coming together. Got 34 kilowatt hours of battery storage. My first video that involved a couple of wires. Come on everybody, let's get the juice flowing. Our own juice. We could all use a little energy independence in our life right now, especially with the way things are going in the world.